The purpose of this video, work demo number 2, lesson number 5. Let's get to it. It's been a while since I've worked this, so I don't remember them. So the data table below contains the amount of the sample of 9 customers spent for lunch at a fast food restaurant. So at a 0.05 level of significance, is there evidence that the mean amount for lunch is different than $6.50? So again, mu equal 6.5 because the the null hypothesis is always equal to, and we're testing to see if there's a difference. So not higher, not lower. So not equal to would be the alternative hypothesis. The critical values, we can cheat a little bit here. So let's do that. Open up the data, go to stat, go to tstat, go to one sample, and go to with data. Why do we choose with data and not with summary? Well, because we have our data. We have our 9 numbers. So I'm going to select the variable, going to manipulate or edit the null alternative hypothesis, and then I'm going to come down and I'm going to show the critical value. Now, I will tell you that sometimes the critical value that you get here isn't exactly correct. Sometimes you have to go into your calculator, but you get multiple attempts at it. So if you enter the critical values from the output, then just run it with a calculator and re-enter. So the test statistic is right here, 0.8739. So since the test statistic is contained in the critical value range, we do not reject. Get this out of the way so you can see it. And so there is insufficient evidence to conclude that the amount is different than 650. Determine the p-value. Well, that comes directly from the chart, from the output, 0.4076. Again, from previous video, the probability, the p-value is the probability that the sample mean is what we got or more extreme, given that the null hypothesis is true. That's the critical component there. What assumption do we make? Well, we have a small sample size. We have something less than 30, right? We only have, I think there was 9. So we must know that the population distribution from which these values are drawn is normally distributed. Typically distributions that are pertain to dollars are positively skewed. So we would need some evidence that we have a normal distribution. And finally, because the sample size is 9, do you need to be concerned about the shape of the population distribution? Yeah, you do. So that's why I chose C. With a small sample, it's difficult to evaluate the normality. So the distribution may be symmetric. And I notice again the light language there. It's not strong language that the distribution is normally distributed. But it may be symmetric because the mean and the median are close in value. So what I did there is I just went to my calculator, I went to summary stat column and selected variable 1 and just went, selected the mean and the median, and 17.03, 17.41, which are relatively close. So that's the reason I chose D. Okay, in a one-tail hypothesis test where you reject H sub O only in the lower tail, what is the critical value for 11 degrees of freedom? Okay, I'm glad this came up. So we can go to calculator, go to T. So we need a lower tail. First of all, degrees of freedom are 11, or is 11. And we need the lower tail to be 0.05. Now notice I don't divide by 2 there because it's a one-tail test. We're told right here, only in the lower tail, right? A one-tail test. A two-tail test, we have to multiply by 2, the p-value. So I would have to, this area right here, I would have to divide by 2 the area to the left. Again, if it was a two-tail test, but it's not. So just go there, hit compute, and you can see that I get the answer that I entered. And I will tell you, it's probably a good time to pump the brakes. If you're still confused about one-tail, two-tail test, then you maybe need to go back and watch or rewatch or re-rewatch, whatever it may be, the instructional videos prior to this lesson. That's where I really went into a lot of depth and detail on those distinctions. So in a random sample of 500 items where 86 were found to be defective, now we're getting into a completely different type of problem. We're getting into a proportion problem, not a mean problem, because it talks about out of 86 out of 500. It doesn't give those keywords like a mean, a standard deviation, mu, x bar. It gives percentage, which can either be given by p or pi. This textbook uses pi, most don't. So I'll talk about that in just a little more. So what I can do here is I can go to stat, go to proportion stat, one sample with summary, and I can enter my information. So I have 86 would be the successes, 500 would be the total number of items, and it looks like we're testing 1.5 against 1.5. Now, again, I don't want to beat a dead horse here, but in some contexts, they will state the population parameter for a proportion to be p. Over here, in some contexts, they will state the population proportion to be pi. So you have to have this on your radar. It's a little bit confusing, but it's just one of those things you have to work through. Depends on, both of them are correct. It's kind of like saying 6 of one, half dozen of the other. Both are saying the same thing. You just need to have on your radar that both are options. Let's get into show the critical value. Looks like they want us to test this at 0.10. And let's say compute. So what you'll see there is the p-value is 0.168, which I registered, or I pulled from the table right there. So since the p-value is greater than our alpha, 0.10, we do not reject H sub O. Question 4, in a recent report, 46% of college internships are unpaid. Oh, that's a bummer. A recent survey of 60 found that 35 were unpaid. Use the 5-step p-value approach at a level of 0.01. All right, gang, let's do it. So successes, I would have 35 out of 60. My hypothesis would be 0.46, my null hypothesis. And my alternative is not equal to 0.46. I like how StatCrunch sets this automatically for you because these numbers have to be the same. So it gets into a situation where you can't make a kind of a bozo error and get the wrong value for the alternative hypothesis. Show the critical value. Again, we are testing at 0.01. I don't know we're going to need the critical value, but let's just grab it anyway and hit compute. So the test statistic is going to be under ZStat, so I pulled that value there. The p-value is under p-value, pulled that value there. The p-value 0.055 is higher than our alpha at 0.01. So therefore, I do not reject. There is not sufficient evidence that the internship is different because the p-value is greater. Now, assume the study found 40 out of 60. So that's going to be easy to do. Just go up, change 35 to 40, hit compute, and we get new stuff, right? We get new stuff because we have a different sample estimate. Instead of 35 out of 60, we get 40 out of 60. So things change. Namely, the test statistic will change. The p-value will change, as I've indicated there. Now the p-value, the result is different from part A, and we end up rejecting because our p-value is less than our alpha value. So there is sufficient evidence that the proportion of college interns that had an unpaid internship is different because the p-value is less than the level of significance. It's one of those things you got to tattoo to the brain. If your p-value is less than your alpha, you reject. If your p-value is greater than alpha, greater than or equal to alpha, then you fail to reject. All right, so we have a claim of 51%. So I put in p equal 0.51, p not equal to 0.51. I'm going to create this information using the calculator. So of 1,000 surveyed, 560. Reported competition for talent is the biggest obstacle at a company. So let's set this accordingly. Make sure we have not equal to. Again, p, pi, same thing. So we've got different notation here. That's okay. Just different way of putting things. Significance level is 0.01, so I have that entered correctly. So let's compute. So the test statistic is 3.16. The p-value is 0.002. We reject. There is sufficient evidence to support the claim that it's different from 0.51. What is the difference between a null hypothesis and an alternative hypothesis? Well, your null hypothesis, I always think of it as it's the lazy hypothesis. It's like, yeah, whatever, it's the status quo. I don't want to worry about it. It is what it is. Somebody said it's 51%. Well, okay, it's the 51%. Corresponding with that right there, the null hypothesis states a status quo case. I think of the alternative hypothesis as being the aggressive one. It wants to question everything. It wants to state every belief contrary to the status quo. So the alternative hypothesis states a claim that is contrary to the null and really represents the motivation for the study. So that's the formal definition of a null and alternative hypothesis. All right, gang, that's it. Now, I hope this helped. Take care.